Hello, everyone, and welcome to another episode of Megan2Mars. I'm your host, Megan Kane, and today we're going to be talking about a fun thing called microgravity. You may have also heard it referred to as zero-G, and we're going to talk about what it actually is. First off, and this may be counterintuitive to you, microgravity is free fall. It is free fall. So it is where the force of gravity is the only real force acting on you. So free fall, like that. Now, normally, gravity is pulling you down, and something like my hand or the table or whatever you happen to be on is pushing up. Okay? Now, if you take away the gravity, if you take away whatever is opposing gravity, you don't feel gravity the same way. So you end up with microgravity. Now, you may have experienced this on, say, a swing, when you're swinging back and forth and you go up high and you just hover. It feels like you hover for a split second and then whoosh. That split second, that is microgravity. You usually get a funny feeling in your stomach. Or maybe you're going on a roller coaster and you go up, 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 and then at the top, and then it falls. That is microgravity. The second where you float. A few other places you can experience microgravity are things like the Tower of Terror or Space Shot at Space Camp. Tower of Terror is at Disney. Space Shot is part of Space Camp. It's actually the first time I realized that I was experiencing microgravity when I was at Space Camp when I was like 13 or 14, something like that. Anyway, free fall is microgravity, because gravity is affecting us, but there's nothing to oppose it, so we don't feel like it's affecting us. Okay, very basics. So, let's, well, I have something to show you. This is when I got to experience microgravity here on Earth. Because in addition to things like the Tower of Terror and Space Shot at Space Camp and roller coasters, you can experience like this in a plane, where you go up, 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 hover, and then you go into free fall. You can experience it for multiple seconds. So this is with the Canadian Research Organization, and we are going up on multiple parabolas. We did both lunar and zero gravity on the flights. This video is a compilation of my microgravity flights. So the parabolas where we floated. You can see I've got my seatbelt holding me down, but I had it nice and loose so that I could hover above the seat, but not so loose that I would float away before, because you only have about 16 seconds of falling in the plane before the engines reignite and it sends you back up. Now you want to be seated for the up part, because you can experience up to 2 Gs doing that. This and I think it's Zero Gravity or Zero G is the name of the other is a name of a commercial company that does them. I can put a link in the description where you can go and do it yourself. Now you can see that the water is floating much more than I am, simply because of the seatbelt. All right, let's talk a little bit about how microgravity on orbit works. Now, on the plane, you experience about 16 seconds while you're falling. However, on orbit, you experience it the entire time you're on orbit. So what happens on orbit is that, well, you can orbit Mars, right? We'll do orbiting Mars. So Mars, yay! If you launch something into orbit, or maybe we should use Earth. Okay. We'll use Earth because I have the numbers for Earth. So in order to orbit Earth, you need to be going about 7.13 kilometers per second. That's a really, really fast. And don't ask me for miles per hour. I haven't the foggiest idea. I could probably look it up. Yeah, I'd have to look it up. Most things that I have memorized for space are in kilometers because, well, I did a lot of training in France at the International Space University. So, Earth. Oops. Earth. Make sure I have the blue side up. Green screens. So, when you are on Earth and you launch, whee! If you launch at, say, 3 kilometers per second speed, velocity, speed, you end up, say, here, part way around the Earth. Maybe 5, you get halfway across the Earth, and that would be what intercontinental ballistic missiles did, and they're the precursors to rockets. So, if you go at 7.13 kilometers per second, you end up in about 400 kilometer high orbit, which is where the space station is. And what happens is that you're going so fast that you fall around. Let's see if I can do it this way. You fall around the Earth faster than the Earth is turning. So you don't hit the ground because you're not moving slow enough to hit the ground. So you're moving too fast to hit the ground. So you end up going around and around and around and around and around and around and around in constant free fall. Now, the reason that people appear to float standing still in like the International Space Station, Skylab, Mir, things like that, is because it is the spaceship is in free fall, the person inside it is in free fall, and they are falling the same. Therefore, as they fall around the planet, they appear to be floating midair relative to their surroundings. And that is how you get microgravity. All right, so that's microgravity on orbit. It's how you can do it. So here on Earth, again, you can do swing is probably your cheapest option, going to the park and swinging on a swing. Although roller coasters, the Tower of Terror, Space Shot at Space Camp, or there's a number of different rides you could go on at various carnivals that have similar free fall aspects. That feeling you get in your stomach, that is microgravity. On orbit, you can experience it a lot longer than we can here on Earth. And that is exactly what I'm experiencing in this video for about 16 seconds at a time. You can actually see above my shoulder where it says the current G's. That's what we forgot to talk about. What is a G? Okay, 1 G is the standard gravitational pull of the Earth. So basically, how fast are we being pulled to how much force is there being exerted on us by the center of the Earth? Now, it varies a tiny bit, but it's all negligible amounts while you're on planet. So, 1G. Well, 1G. We've experienced 1G. Let me switch to Mars. Haha. Okay, Mars is not 1G. We'll switch back to Earth. Okay, Earth. You experience 1G. 1G pulling you down on Earth. The moon is 1/6 of a G. Mars is about 1/3 of a G. And 1G is, again, the pull of the center of the Earth on us. Now, there's a big complicated equation that you probably don't want to see that we use to calculate out what the gravitational pull of any particular body, like the Earth, is on another body, like, say, you. So you can you can calculate out based on how far they are away apart from each other. It's based on how far apart they are, how big they are, what their mass is. Okay, it's complicated. I'm not going to go into it. But basically, when you're on Earth, near the Earth's surface, you experience 1G. Okay? And we use that to explain, relative to what we're used to here on Earth, the gravitational pull of other celestial bodies like the Moon, Mars, etc. Fun fact, when you're on orbit, you experience like 85, 89% gravity that you do. So 0.8, 0.89, something like that. I don't remember the exact figure. But you experience most of the gravity that you do on Earth. It's just you're in free fall. So you don't actually feel it like you would here on Earth. All right, and that has been Microgravity on Megan2Mars. Like, subscribe, and check out the links in the description for my Instagram videos of my lunar gravity and my full microgravity videos. Thanks!